All right, 7.3, binomial radical expressions. So here we're going to be combining like terms. It's just going to be fancy combining like terms. So starting off with a new definition or an idea, we have like radicals. Now think about whenever we talk about like terms, where they both have an x, you can put them together, you can add them up. Here, the whole idea of this is going to be like if we have 2x plus x, that's 3x, right? That's the idea that we're going to be using in this lesson. So like radicals have the same index. That means like they're both the square root or they're both the cubed root, and the same number under the root. Okay. So another way to say this would be that they are how do I want to say that? They are both of the form, I'll say the nth root of a, right? So they both have the same thing underneath the root, and they both have the same radical, the same index. All right, so looking at some examples where we actually use this, we'll go with number 1. We have 5 cubed root x minus 3 cubed root x, and we're supposed to simplify. We're supposed to simplify, or I think it says subtract. We're supposed to subtract or simplify. Well, think about this as if it was just 5x minus 3x. Well, 5x and 3x would give us 2x. But what we're dealing with here is we have the cubed root of x, so this is going to be 2 cubed root of x. All right, hopefully that's not too crazy. Let's look at the next one, number 2. We have 2 root 7 plus 3 root 7. Well, just like in the last one, we can add those together because they have a like radical. And we can say, well, this is the same thing as 5 root 7. All right, moving on. Number 3. So here we're going to have 6 root 18 plus 4 root 8 minus 3 root 72. All right. Notice that these are not all the same root. They are not like radicals. So whenever we're giving something like this, the beginning of it, we should simplify our root, right? So we're going to make a little factor tree on the 18, the 8, and the 72, and see if we can make these radicals more simple, simpler, yeah. So 18 splits up into 9 and 2, which splits up into 3 and 3. So we have a pair of 3's and a single 2. So my 3's will come outside and turn into 1 3, so I'll have 6 times 3, and then under my root I have 2. All right, dealing with my next term, I have my 8. Well, that's 2 and 4, which is 2 and 2. So I have a 2 that comes outside. So I have 4, and then a 2, and then underneath my root, I still have a 2. Lastly, I'm going to have negative 3 times, breaking up our 72. 72 will break up into 36 and 2, which is 6 and 6. So I have a pair of 6's and a single 2. So I have my negative 3 outside, I have a 6 that comes outside, and then underneath my root I have a 2. To continue on, we're going to multiply these together. Oops, hold on. Did I mess up here? No, I'm okay. Okay. 6 times 3 gives me 18 root 2 plus 8 root 2 minus 18 root 2. Right? Now these all have root 2's in them, so we can combine them. But what's kind of convenient here is that we have 18 root 2 and negative 18 root 2. So we can just kind of cross those out because they cancel each other. And then we're left with an 8 root 2. And there we are. All right, moving on to number 4. Now this one we're still simplifying, but we're going to be multiplying. So here, let me write this in orange. we're going to have 3 plus 2 root 5, and then 2 plus 4 root 5. And we're supposed to simplify this. We're still going to be dealing with the old idea of foiling, or whenever you distribute things and you have to distribute to there, and to there, and then to there, and to there. That's what we're going to be doing with this. So starting off, I'll have 3 times 2 gives me 6. 3 times 4 root 5 will give me 12 root 5. 2 root 5 times 2 gives me 4 root 5. And then 2 root 5 times 4 root 5 will give me, well, I'm not going to fully simplify this. I'll say that this is 8 root 5 squared, right? I have 2 5s. So I'm going to try to simplify this a little bit. I'll have 6 plus my 12 and my 4 go together to be a 16 root 5 plus 8 times 5. So this is 6 plus 16 root 5 plus 40, which is 46 plus 16 root 5. There we are. So that's how we would multiply them together. Multiply the two numbers with radicals in there, right? You might remember that it kind of looks like a complex number there, but it's not a complex number because it's a root and not an I, right? But this is kind of similar to what we did there. All right, looking at number 5. Let me write this in orange. I'm trying to write my problems in orange. Number 5, we're going to say 5 root 2, excuse me, that's not what it is. Root 5 plus root 2. And then we're going to have root 5 minus root 2. Now, I don't know if this is a word that we know yet, but these are actually called conjugates, okay? And I just want to give you a quick little definition of a conjugate. A conjugate normally we think of it as a pair of numbers, so a pair, right? A conjugate is formed by changing the sign between a binomial. So if you are given a plus b, that's a binomial because it's two terms that are added together. The conjugate would be a minus b, right? You change the sign there. If you were given a minus b, then you would go to a plus b, right? All you have to do is you change that sign in there. And what we're going to see is it does some fancy stuff with roots, helping us out. So whenever we multiply this out, I'm going to have root 5 times root 5. Well, they're both the same thing, so this is just going to be 5. And then for root 5 times negative root 2, well, the 5 and the 2 go together to be a negative 10, or negative root 10. Root 2 times root 5 will be positive root 10. And then root 2 minus root 2, or times negative root 2, will be a negative 2. So hopefully we're seeing the fancy piece that it does here. These guys will cancel, right? So then I'm just left with 5 minus 2, which is 3. So conjugates can help us get rid of roots. And we're going to use that whenever we have ugly denominators that we need to rationalize. So let's look at number 6. Number 6, we are going to rationalize the denominator. Remember, we can't end a problem with a root in the denominator. So I have 3 plus root 5 over 1 minus root 5. So we're supposed to rationalize the denominator. So say you're doing some random homework problem, and you end up getting this as your answer. And if you get this as your answer, you can't be finished yet, right? You have to rationalize that denominator. That root 5 that's in the denominator cannot stay there. What we're going to do here is we're going to use a conjugate. So just like in number 5, how they canceled the roots out, we're going to do that same thing. We're going to create a conjugate of the denominator. So my conjugate is going to be 1 plus root 5. And you rationalize by multiplying by a fancy 1. Like a fancy, you're more multiplying by 1. And in order to do that, we have to have the top and the bottom be the exact same thing. Right, so the top and the bottom are 1 plus root 5. Now we can multiply. I'm going to start off by, how do I want to do this? I'll do the numerator first. So really we could think about this as here's my parentheses, and I need to multiply them together. So I'm going to have 3 times 1 is 3. 3 times root 5 is 3 root 5. Root 5 times 1 is just plain old root 5. And then root 5 and root 5 gives me 5. All right, so that's just my numerator. My denominator, I'm going to take 1 times 1 is 1. 1 times root 5 is root 5. Negative root 5 times 1, so negative root 5. And then root 5 and root 5 gives me a negative 5, right? It's a negative root 5 there. So we see that these guys in the middle, just like in number 5, cancel out. So now simplifying, my numerator, my 5 and my 3 will go together. 5, 6, 7, 8. And then my 3 root 5 and then my 1 root 5 gives me a 4 root 5. Now my denominator combines together to be 1 minus 5 will be negative 4. So we can leave it like that. Actually, we can do even more. We see that this 8 and the 4 can cancel out, and the 4 and the 8 can cancel out. So this is actually going to turn into, what can we turn this into? 8 divided by negative 4 will be negative 2. 4 divided by negative 4 will be negative 1. So that's our answer there. Now, if that was hard to see, the second to last step to the last step, let me show you another way that we can kind of think about it. We have a 4 on the bottom, and we want to cancel that out. So what I'm going to do is I'm going to factor out a 4 from the top. Right, I factored that 4 out. Now I can cancel this out, and I'm left with a negative 1 in the bottom. So what I'm going to do is I'm going to pull that negative 1 up top. So it's going to be a negative 2 plus root 5, which is going to be negative 2 minus root 5. Right. A lot of the time we don't write that work down, but that is what we're doing. All right, that's the homework, or that's the notes. All you're going to have to be doing here is you're going to have to rationalize the denominator sum, but all of it falls under that umbrella of combining like terms, right? Make sure that anytime you get confused, if they have really ugly roots, like if you have like 1 plus root 18 minus root 6 plus, if you have something really ugly, start to think about it, well, what if this was just a plain old x? What if something was a plain old y, right? If you have 2 root 2 plus 5 root 2, and you're like, I have no idea what to do. Think about what if this was 2 root x plus 5 root x, or just 2x plus 5x. Think about it in those kind of terms. And then I think it makes it a lot easier, right? Go back to what we learned in middle school or whatnot and use those ideas. So, all right, that's that.